I thought we'd start off today just by looking at these two examples that this is really from what we did on the last lesson from the 9495 and what you practice on your homework assignments. I thought I'd go through a couple of them just to make sure that we have it down. If you want to, you can pause it right now and you can work them through on your own and then check with what I do. Okay, to solve this first triangle, start with the angle that you know. I know angle A, it's 28 degrees. I want to find out what x is. That is the hypotenuse. And I know what 16 is. That's the adjacent side. So now I've got to figure out the right trig ratio to set up. So our choices are sine, cosine, and tangent. So I'm going to start by choosing that. So remember our SOHCAHTOA. So choose the correct one. I'm trying to find the hypotenuse. I know the adjacent. So hypotenuse and adjacent is the cosine. So my equation is going to be the cosine of my angle, which is 28 degrees, equals the adjacent side, which is 16, over the hypotenuse, which is x. Okay, I've got my equation set up. Now all I have to do is solve for x. So I'm going to times by x on both sides. Get the x off the bottom of the fraction. Okay, now we're going to write my new equation now is x times the cosine of 28 degrees equals 16. Divide by the cosine of 28. Okay, now I'm just going to plug down my calculator. So 16 divided by the cosine of 28 degrees. Cosine of 28 is just a ratio. So in the calculator, we'll figure out what that's equal to for us. So 16 divided by the cosine of 28, put it in our calculator, and we get the x is approximately 18.1. That seems right? My hypotenuse should be longer than both of the other two legs, so it's longer than the 16. Okay, the second equation again, to decide what angle you're going to use, we're going to use angle B. It's a right triangle, so we can use our trig function. So x is the adjacent side, okay, and 13 is the opposite side. So I got to pick the right trig ratio. So if I look up there, this one is the TOA, the tangent. So I'm going to go the tangent of my angle, which is 63, is equal to the opposite side over the hypotenuse, over the adjacent, excuse me. Okay, now we're going to solve that times by x on both sides, times by x on both sides. X tangent of 63 equals 13. Divide by the tangent of 63. Again, grab a calculator, plug that in there, it'll do the rest of the work for us. Just a reminder, make sure your calculator is always set to degrees on these problems and not radians. So tangent of 13 divided by the tangent of 63. Plug in our calculator, it comes out to be 6.6. So that's a quick review of just what we did yesterday. If you got questions on that, make sure you send it to me and you ask, and I'll answer some questions and go through some stuff. Okay, today this is our learning goal. We're going to keep solving right triangles. Solving a right triangle means to find the missing parts, whether it's sides or angles. And we're also, as part of that, we're going to use inverse trig ratios, and we'll talk about what that is in just a second. So here's a problem right here. It says determine which of the two acute angles has a cosine of 0.5. So remember, cosine is equal to the adjacent over the hypotenuse. We want to find out which of those two angles, either A or B, come out to be 0.5. So let's just try it. If I try the cosine of A, so if A is my angle, that means the opposite side is 1, the hypotenuse is 2, and the adjacent is 3, square root of 3. So if I do cosine, it's adjacent over hypotenuse. That'd be square root of 3 over 2. That does not equal a half, so it's not A. If we switch things around, we can find out what is the cosine of angle B. So I come up to angle B. Now when we do that, now this side becomes, the square root of 3 becomes the opposite side, and the 1 becomes the adjacent side. So now if I find the cosine of B, it's equal to the adjacent, which is 1, over the hypotenuse, which is 2, and it comes out to be a half. That's my answer then. It said the cosine of which angle is 0.5. It's the cosine of angle B. What we want to look at today is we can actually find those angles. So let's say you're given an equation like this, like we just had. We have the cosine of angle B equals a half. So we know what the ratio is equal to, but we want to work backwards and find out what the angle is equal to. Okay, so we know what the ratio is equal to. We want to work backwards to find out what the angle is equal to. When we work backwards in math, we're trying to undo an operation. That's called an inverse operation. So in your calculator is actually a button. Let me show this to you. So if you write this down, if the cosine of B equals a half, that means that the B is equal to the inverse cosine, and the inverse sign is that little -1 I just wrote right there. It's that inverse cosine of a half. So I plug a half into the inverse cosine, and that will actually work backwards and tell me what angle B is equal to right there. Okay, come up and tell me that. Okay, and this is just a calculator problem. I'm going to show you how to do that. So again, the reason why you do this, come back up here. This is when you know what the ratio is equal to, and you want to work backwards to find out what the angle is equal to. That's when we do the inverse. That's when we do the inverse of the cosine. So if you get a calculator, I'll show you what this looks like on the graphing calculators up here. You can do it on any scientific calculator, sine, cosine, and tangent, and you can do this. You can use it. You'll also have an inverse cosine, inverse sine, and inverse tangent button. So on these graphing calculators, if you look here, the inverse sine, cosine, or the sine, cosine, and tangent buttons are right here. Sine, cosine, and tangent. And then if you look above it in blue, it's kind of hard to see, but there's the inverse sine, inverse cosine, and inverse tangent button. So one thing to be aware of, I talked about this earlier yesterday, but if you hit the mode button, which on these calculators is here, different calculators is in different spots, you want to make sure that the calculator is set to degrees. Let me just zoom in a little bit here and see if it will focus a little bit better. It's thinking about it. Okay, so that looks a little bit better. So anyway, just make sure down here that it's not set to radians. You see my calculator set to radians. I want to make sure it's set to degrees, so I'm going to highlight it like that. Then I'm going to hit second quit to get out of there. Okay, once I'm back in here, I just want to plug in. So go to where cosine is, but you have to hit second cosine, which brings up the inverse cosine. And there I'm going to put a half, hit enter, and it tells me the angle is equal to 60 degrees. That should make sense to us. I don't know how many of you recognized, but this triangle, this angle over here, decided that was for angle B. That was equal to 60 degrees. So I don't know if how many of you recognize, but this actually is a 30-60-90 triangle, which we talked about earlier, right? I have, if the short side is 1, the hypotenuse is double that, and the long side is 1 times the square root of 3. Okay, and that gives us that. So this inverse sine, inverse cosine, and inverse tangent is always to find an angle. This is from the book, but this is like the rundown of this, right? Inverse tangent, right? If the tangent of A equals x, that means that the inverse tangent of x equals the measure of angle A. It tells you what angle A is equal to. Or if the sine of A equals y, then if I do the inverse sine of y, it tells me the measure of angle A. So it's just working backwards, right? The cosine of A equals z. That tells me the inverse cosine of z equals angle A. So we can always work backwards to find out what those angles are equal to, and I'll show that to you right here. Okay, this is really simple. This is really just a calculator problem. It says let A, B, and C be acute angles. Hey, right triangle trig only works with acute angles. Use a calculator to approximate the measures of angle A, B, and C to the nearest tenth of a degree. So we're going to do angle A and B. So if I know that the tangent of A equals 0.75, we want to work backwards and find the angle. So we do that with the inverse. I say the angle A is equal to the inverse tangent of 0.75. And now that's just a calculator problem. I plug that in my calculator and find out what it comes out to. So the inverse tangent, second tangent of 0.75 equals 36.9 degrees. So the measure of angle A equals 36.9 degrees. We have that. Okay, let's do that next one. If the sine of B equals 0.87, I want to work backwards. I want to find out what the angle is. So when I work backwards, I do the inverse. So the measure of angle B equals the inverse sine of 0.87. Once you do that, that's just a matter of plugging it in your calculator. So again, I go inverse sine. I put in 0.87, plug in my calculator, and we get 60.5. So the measure of angle B equals 60.5 degrees. So again, this is just a way to work backwards and find the angles. Okay, this is important because we're going to be solving triangles, and so we're going to have to think backwards here. So if I skip ahead here, it says, right, if you solve a right triangle, it means to find all of the unknown side lengths and angle measures. You can always solve a right triangle if you either have two sides or you have one side and one acute angle. As long as you have those two things, then you can always solve for the other sides or the other angles. Okay, so here's an example. So solve the right triangle, round your decimal answer to the nearest tenth. So if I come over here, this means I have to find all of the sides. I have two of the sides, but I need to find the third side, and I need to find these two angles right here. I need to find that angle and that angle. Because I have two sides, I can find the third side just using Pythagorean theorem. So I'm going to use that. I'm going to go 2 squared plus 3 squared equals c squared. So 2 squared is 4, 3 squared is 9, 4 plus 9 is 13. Take the square root, so c is equal to the square root of 13. Put that up here. So c is equal to the square root of 13. Okay, but now I've got to find these two angles, and I can't find those two angles using Pythagorean theorem, so I'm going to use either sine, cosine, or tangent. Actually, inverse sine, inverse cosine, and inverse tangent. So I'm going to pick an angle to find first. Let's say we're finding angle B, and you pick two sides to use. I know all three sides. I know 2, 3, and square root of 13. Let's label them all. This would be the square root of 13 is the hypotenuse. 2 is the opposite, and 3 is the adjacent. Because I know all three sides, I can choose whether I want to use sine, cosine, or tangent. I think I'm going to use tangent this time. Tangent is opposite over adjacent. So I'm going to say the tangent of angle B. So the tangent of B is equal to the opposite side, which is 2, over the adjacent side, which is 3. Now this is like the problem, right? I know the answer. I know what the tangent equals. I'm trying to work backwards to find the angle. So whenever that happens, we're going to do the inverse tangent. So angle B is equal to the inverse tangent of 2/3. Okay, so grab a calculator, plug that in there. So mine, I'll put this one in I'll show you the calculator up there on this one. Kind of see how this works. So there's my calculator. I'm going to zoom in a little bit. And we want to just put in that inverse tangent. Just fix one thing here. Okay, so we're going to go on there. We're going to do the inverse tangent. Remember the inverse buttons are right here, right above the sine, cosine, and tangent. So second inverse tangent of, and I want to do 2/3. Plug that in there, hit enter. So 33.7 degrees. So let's put that down there. So angle B up here is 33.7 degrees. Now I also need to find angle A. You could set up a trig ratio with it, but if I already know angle B and I know angle C, I could just subtract them from 180 to find angle A. So I'm going to go 180 minus 90, which is angle C, minus angle B. Plug that all in a calculator, and that ought to tell me what angle A comes out to be. So 180 minus 90 minus 33.7. There's my other missing angle, so 56.3 degrees. Okay, now I've solved the right triangle. I found my missing angles. I was missing angle A and angle B, and I know angle C was 90. I know side C, I know the other two sides also. Okay, so I've solved the right triangle. Okay, let's do another example. Okay, so on this one, number 6, again, I have two sides. I'm trying to find the third side. Let's actually do 7 instead. I still have two sides. I'm trying to find the third side. So I'm going to start out by finding out what this side, we'll call it side H over here is. So let's go 91 squared plus H squared equals 109 squared. So I'm going to square 109, subtract 91 squared from it. So 109 squared, 11,881 minus 91 squared. And I end up with H squared is equal to 3,600. Take the square root of that, of 3,600, and you end up with 60. So H equals 60. So we're going to come up here and let's fill that in. H is equal to 60 up here. Okay, so now I've got all three sides. Now I need to find the missing angles. So pick an angle to find first. Let's say I'm going to find angle G. Because I know all three sides, I can use sine, cosine, or tangent. It doesn't matter. So let's just pick one. Let's do sine this time. So I'm going to say the sine of angle G is equal to, and sine is opposite over hypotenuse. So it'd be 91 over 109. Okay, again, this is where I got to work backwards. Whenever I'm trying to find the angle, when you're trying to find the angle, use the inverse. Okay, got to remember that. When we're trying to find the angle, use the inverse. So I'm going to do G is equal to the inverse sine of 91 over 109. Okay, grab a calculator and plug that in there. Inverse sine of 91 divided by 109. And I get 56.6. So I'm going to come up here. That angle is 56.6 degrees. Okay, now I've got to find angle H. But if I already know these two angles, I can just subtract them from 180. So H is going to equal 180 minus 90 minus 66.6. You plug that in the calculator, and it comes out to be 23.4 is my other angle. Okay, so I've solved that right triangle. Hey, let's do one that's just a little bit different, where we have a side and an angle, rather than, like this is a good example right here. So I have a side and an angle, but I don't know the other two sides. Hey, if this happens, make sure you make things as easy as you can. If you look up here, if I know this angle and this angle, I can find that angle, right? Just subtract it from 180. So 180 minus 90 minus 25. So we plug that in our calculator or our brain. I'm pretty sure it comes out to be 65 degrees. And that's going to go right there. So I know all my angles now. So all I have left is find side G and H. Okay, so let's start. Let's say I want to find side. Pick an angle. You can never use the right angle. It's got to be one of the two acute angles. So I'm going to say I'm going to use angle H, which is 25 degrees. If I do that, then H would be the opposite side. G would be the adjacent side. And 13 would be the hypotenuse. Okay, when I set up my equation, I only want one variable. So I am not going to go opposite over adjacent, because that'd be H over G. I'm going to do opposite over hypotenuse because I know what the hypotenuse is. So opposite over hypotenuse, think of SOHCAHTOA. Opposite over hypotenuse is the sine. So I'm going to say the sine of 25 degrees is equal to the opposite side, which is h, over the hypotenuse, which is 13. If I solve that equation, I'll know what h is equal to. This is a pretty easy one to solve. Hey, we're not trying to find an angle. I know what the angle is, so this is not an inverse problem. Just times by 13, just what we did yesterday, times by 13. So h is equal to 13 times the sine of 25 degrees. Okay, grab a calculator, plug that in there. So 13 times the sine of 25, and we end up with 5.5, or approximately 5.5. Okay, I'm still missing a side. That's side h over here, so we can add that in here. It's 5.5. I still need to find g. So we can set up another trig ratio. If I use h again, g is the adjacent side, and 13 is the hypotenuse. So I can go the cosine this time, right? SOHCAHTOA. Cosine of 25 equals the adjacent, which is g, over the hypotenuse, which is 13. Okay, solve this equation from here. Times by 13, cancels that out. Make sure you times the other side by 13. That's what g should equal. So grab your calculator again. You're going to put in 13 times the cosine of 25, and you get 11.8 is what it comes out to be. Okay, we solved the triangle. We found all the missing angles. Notice with the angles, I didn't have to do any trig at all. For the missing sides, I did have to do some trig in order to find that. That really is all there is on the problems. There are a couple application problems, so we'll look at like one or two of those. So here's one right here. It says your school is building a raked stage. The stage will be 30 feet long from front to back with a total of a 2 feet rise. So you can see the 2 feet rise right over there. You want the rake angle of elevation to be 5 degrees or less for safety. Is the rake stage within your desired range? So what we're trying to find out is this angle right here, it says it's an angle of elevation. So is this x right here? Does it fit between that, 5 degrees or less? So let's find out what x is, right? So I know two sides. If this is my angle right here, right? This is the angle x. This 2 is the opposite side. And 30 is the hypotenuse. Make sure you pick the right trig ratio. So I have opposite and hypotenuse, so think of SOHCAHTOA. That's the sine. So I'm going to go the sine of angle x that I don't know equals the opposite side, which is 2, over the hypotenuse, which is 30. Okay, this is really important. Now we're trying to find an angle. If I'm trying to find an angle, that means I always do the inverse. So x is going to equal the inverse sine of 2 over 30. That's what we're going to put in our calculator. So grab your calculator, inverse sine of 2 divided by 30 comes out to be 3.8. So this angle down here is 3.8 degrees. It said it was safe, or it was good if we wanted to be less than 5 degrees. 3.8 is less than 5 degrees. So is it within our desired range? We would say yes. So important things there, guys. Make sure you pick the right trig ratio. And the way you do that is by identifying the information you're given. On those previous problems, we knew all three sides, so I could choose sine, cosine, or tangent. On this problem, I only know the opposite and the hypotenuse, so it has to be sine because sine is opposite over hypotenuse. And then just remember, if you're trying to find an angle, it's always the inverse function, either inverse sine, inverse cosine, or inverse tangent. I'm going to skip past. Actually, let's go back here. Take just a second. You guys try this problem. See if you get it. So pause the recording. Write this problem down and work through it. And then I will come back and we'll finish this one. This will be the last thing we do. But you guys go ahead and try it on your own first. Okay, let's work down through this. So it wants me to solve the right triangle. That means I need to find side Z, side X. I know this side. I know this side over here. And I'm also trying to find the angle Y. Angle Y, start with the, go for the low-hanging fruit. Angle Y is the easiest one. If you've got two of the angles, we just have to find the third one. So let's go 180 minus 90 minus 52, and that should tell us what angle Y is right there. So plug that into your brain or your calculator or whatever you're using. And we end up with really 90 minus 52, so it's 38 degrees. So angle Y is 38 degrees. Okay, now the part we're going to have to use trig for is we're going to have to find out what side Z and side X are. So pick an angle. In this case, I know angle Y. Angle Y is 38. I know angle X, which is 52. And so you can pick either one. It doesn't matter. So let's say I use angle X up here. Okay, so if I'm trying to find side X down here, this would be the opposite side, and Z would be the hypotenuse. Okay, I've got to pick the right trig ratio that involves the opposite side. Actually, I'm sorry. That's not going to work. If I come back up here, I don't know either of those two. So I've got to use this side over here, which is the adjacent side. So let's pick the trig ratio. If we're trying to find X, let's pick the trig ratio that involves the opposite side and the adjacent side. So that would be tangent. So I'm going to go with the tangent of 52 is equal to the opposite, which is X, over the adjacent, which is 8.5. Okay, this would be my answer if I solve it. So I'm going to times by 8.5, times by 8.5. Those cancel out. We're going to plug that in our calculator. So we're going to go 8.5 times the tangent of 52. And that gives me 10.9 if I round it off. So X is equal to approximately 10.9. So I'm going to come over here. This side is 10.9. Okay, the only thing I'm missing now is the hypotenuse. I can now use either the adjacent side or the opposite side. Just be careful. The opposite side is rounded, so if I use it, my answer won't be as accurate. You can use it, it may just be off by a little bit. So I'm going to move the adjacent, I'm going to use the adjacent side. So if I use this would be the adjacent. This is, Z is the hypotenuse. So adjacent over hypotenuse is cosine. So let's put that down. I have the cosine of angle 52 equals the adjacent side, which is 8.5, over the hypotenuse, which is Z. Okay, so if I want to solve for this, I got to times by Z, times by Z, times by Z. Those cancel out. I have Z times the cosine of 52 equals 8.5. Divide by the cosine of 52. Okay, plug that in my calculator, and that ought to give me my final side that I missed in there. So 8.5 divided by the cosine of 52 degrees. Plug it in there, it comes out to be 13.8. So I come up here, this side is Z is equal to 13.8. Now I've solved my triangle. I know all three of my sides, and I know all three of my angles. Okay, so that's the triangle is solved. So it takes a little bit of practice, things to remember. Make sure when you're picking the trig ratio, if you only know two of the sides, always choose, you have to choose the correct trig ratio. If you know all three sides, you can choose. You can use either sine, cosine, or tangent. Make sure as you go through your assignment, any questions you have on problems, make sure you write them down, like what numbers. Send them to me, and then tomorrow before I put out before we go on, I'll have a little video that have some helps in there for you. All right, thanks.